Right. What did we learn in the previous class? So, firstly, we learned about the common forces in mechanics, right?
Yes, sir.
The first thing that we learned was this force of attraction due to gravity. Due to gravity, right? So, whenever some mass is there, it will be attracted by the Earth at the center of the Earth with acceleration which is equal to g, right? And the force would be mg, right?
Yes,
This
sir.
this we learn, and then the second force that we learned was the normal reaction. So whenever two surfaces are touching each other, right? So then they will experience some force, right? So we have this surface. So this will apply some force, and this surface will apply some force. So, and this would be perpendicular to each other. So this surface will apply the force in this direction, and this surface will apply the force in this direction, right? Both would be. And then we learned about, and let's say that the surfaces are like this, right? The two surfaces are like this. So this will apply some force, normal reaction in this direction, perpendicular to this surface, and then this will apply. So this surface will apply a perpendicular force in this direction, right? This is N. So this we understood in the previous class, right?
Yes, sir.
And then the third thing that we learned was, what was the force? Yeah, what was the third thing that we learned?
Sir, tension.
Tension, right? So we learned tension. So we have some string, right? And some mass is hanging with this string. So this string will apply some tension on this block, and it will be against the direction of this block, right? So this will be in this way. So this is tension, right? And let's say we have two objects which are tied with some massless string, right? So this is massless. Then let's say this is M1, this is M2. So it will experience, this block will experience opposite to its direction, in this direction tension, and this block will experience some tension in this direction. Clear? Both the tension are equal because we have this massless string. Otherwise, it would have been different. So these are the forces that we learned in the previous class, right? Right, everyone?
Yes, sir.
And then we learned about the free body diagram. So then I said that this was very important. Then we learned about this free body diagram. So it says that we have to isolate all the individual masses from system. Masses, or let's say, or point where the forces are acting, right? So isolate all the individual masses or point where the force are acting from the whole system. And then mark all the forces, right? Except except the force applied by the object or by the mind. So these are the crucial things that we did in the previous class, right? And then we understood about equilibrium, but what you guys do is that you guys quickly note it down this part again, so that you guys, yeah, you guys quickly note it down.
Okay, sir.
So whenever you repeat things again and again, then it would be so you guys will remember it longer, right? So that is the purpose.
Sir,
Yes,
Yes,
sir.
yes, Amna.
can you explain free body diagram?
Yeah. So okay, first to note it down, and then I will explain this free body diagram in a with some example. In that way,
Okay.
you can, yeah. In that way, you can learn it better. So quickly note it down, and then tell. So whenever,
Finish, sir.
yeah, finished. Whenever you see surfaces, you apply normal reaction. Whenever you see strings, you apply tension. Whenever you see object hanging, so you apply the weight, which is the force due to gravitation. So in here it is also experiencing weight, but we'll talk about that later. Okay, so whenever you guys have finished noting this part, tell me so that
Finish, sir.
finished. Okay, then note down this part. Yeah. Whenever you guys have completed noting it down, then we'll see what is the meaning of this free body diagram. Okay.
Done, sir.
Then Rishida, Akib, Elham, what
Yes,
say?
sir.
Yes, sir.
Okay, so as Amna asked, what is this free body diagram? So let's say that I have this ground and some mass is kept on this ground. Okay, so this is the surface of this mass, right? So how many forces are there which are acting on this mass? Right. Let us write all the forces. So first we have this surface. This ground is uh, putting some force on this block, which is the normal reaction, right? And then this block is also experience the gravity. So it is also experiencing the gravity. Let's say its mass is m, so this is m, right? But this block is also applying some force on this surface, right? In this direction. And what is this? Yes. What is this?
Surface.
Yeah.
Surface.
Yeah. So what is normal reaction? Not the surface. That is normal reaction, right? So
Yes, sir.
this surface is applying the normal reaction perpendicular to this surface, and then this block is also applying the normal reaction perpendicular to this surface, right? But if we count the free body diagram, so if we separately write this mass, right? So if we write the free body diagram, so there are how many forces? This is one, this is this one is two, and then this one is three, right? But how many we will write? So we will write which is applied on this block, not by this block. So we will write the gravity, right? The weight and this normal reaction. So this is the free body diagram of this block. Is this part clear, Amna?
Yes, sir.
So this is what we do in the free body diagram. We separately, so in this question, we had only one block, but we'll have different blocks and we will see that how can we write. How is this body diagram is very crucial. So we will see that in a okay. But this is how we write the free body diagram. Okay. We write all the forces and we neglect the forces which are applied by this block. We only assume the force which is applying on this block, not by this block. Understood?
Yes, sir.
Okay. Then we were understanding about the equilibrium. So right. So I forgot to tell you guys about the types of equilibrium, right? So equilibrium has two types. Okay, what is the meaning of equilibrium? So equilibrium means that the net force acting on that object is how much? Yes, at equilibrium, this I have already told you. What is the net force acting on that object at equilibrium?
Zero.
Right. So we calculate all the forces, and if it is zero, so we see that that object is at equilibrium. Okay. But how many types of equilibrium do we have? So we have two kinds of equilibrium. One is the static equilibrium, and the other one is dynamic. So for the static equilibrium, the body is at rest. And the net force, as you already know, this is zero, and velocity is also zero, right? Because it is at rest, so velocity is zero, right, guys? But
Yes, sir.
what happens for the case of dynamic equilibrium? So the body is moving, right? Body is moving, and if F net is zero, which means that your acceleration is zero, right? So in this case also acceleration is okay. Same case for here. So F net is zero, and your acceleration is also zero. But what is V in here? In this case, what is V? Can you guys tell?
Minus
minus if you guys were present in the JE and NEET class, Rishita and Akib.
Yes, sir.
Remember? So, in which case we found out that acceleration is zero. So, you guys saw that example.
Yes, sir.
What was the velocity for that case? Yes.
Sir, when speed is constant.
Oh, good. So, V was constant. Good. So, you remember. Right? If V is constant, then our acceleration is right. So, which means that at dynamic equilibrium, the body is moving with some constant speed. Right?
Yes, sir.
Understood, everyone?
Yes, sir.
Good. So you guys, please note it down. So this was about equilibrium. Now we will solve some examples and then we will use the free body diagram and then we'll use this equilibrium property. So you guys will see that. Yeah, you guys will see that in the example that what is. So whenever you guys have noted it down, please
Yes, sir.
finish. Vishira, Ilham, and Am. What about you guys?
Yes, sir.
Yes, sir, done.
Okay, so now what do we have? Let us take very simple example of equilibrium. So that you guys have came across, right? So and these are precisely the static equilibrium that we will solve. So which means that the object is at rest. Okay, so now let us take this example. This is the object, right, which is placed on the ground, and then it is experiencing the weight, right? Let's say its mass is, let me write it as smaller. So this is mg, okay? And then it is experiencing the normal reaction due to this surface. And it is also applying some normal reaction to this surface. But if we write the free body diagram of this object, right? So what will be that? This is M, so it is applying mg, and then this is normal reaction, right? And this object is at equilibrium. It is not moving, right? So when can that happen? When will that happen? The object is not moving. When will that happen? Yes. When will that happen, guys? So let me ask you this question: that if this normal reaction is greater than this mg, so you are pulling it upward with a greater force than this gravity. So will this object will remain in this place?
Yes, sir.
It will remain if you are pulling it with the
Sir,
No,
but
greater.
sir.
gravity's force is greater, right?
Yeah. So if you are pulling it upwards with the greater force, normal reaction is larger, then it will move upwards, right?
Yes, sir.
You will lift it up. So this is not moving, which means that whatever the force you are applying in the upward direction, that is equal to the whatever force is applying in the downward direction. Am I making any sense? Am I clear?
Yes, sir.
So at equilibrium, right? At equilibrium, right? Your n would be equal to mg. Is this part clear to everyone?
Yes, sir.
Okay. Okay, so this is what I mean by equilibrium. Okay, and if I tell you that how the net force is zero, so you guys know that F net is zero, right? So
Yes, sir.
we can also understand it in this way that F net is zero. How is this zero? Let's say that what would be F net? F net would be this is n, and what is the direction of this n?
Plus,
Plus what?
plus n.
No, no. N is in which direction?
J.
J, right? So n j hat,
Yes, sir.
and then you have this mg. What is the direction of mg?
K, sir.
A.
K, K.
K meaning that it is coming outwards, but it is going downwards.
Minus J.
Minus j. Everyone is this okay? Yeah. So is this correct, everyone?
So can you explain why is it minus J?
Yeah. So let's say that you have this coordinate. So this is x, this is y. This is moving or going upward is j, right? This you understood?
Yes, sir.
So going down is what? This is minus j. You are going in the
Yes, sir.
opposite direction. If you are going in the x direction, that is I, and if you are going in the left direction, so minus I. So that is why you have this minus j. Understood?
Oh, yes, sir. Yes.
Okay. Good. So now if we simplify this, this is nj and this is minus mg. So magnitude is how much? Magnitude is n minus mg, and that is zero. Okay, which means that n minus mg is zero, which means that n equals to mg. So this is what you get from the equilibrium condition. And you guys can see it pictorially also. So when you see this picture, this is upward force, this is downward force. And at equilibrium, both the upward and downward force will be equal, right? That is what we mean by equilibrium, right?
Yes, sir.
So that is how this normal reaction at equilibrium would be equal to this temperature, which will keep this block at this position. Okay. So is this part clear to you guys?
Yes, sir.
Okay, so please note it down, and then we'll do this some complicated questions.
Okay, sir.
So first thing is, as I've said earlier, that this free body diagram is the most important part. So you guys just remember this, but don't apply this one. You just remember that upward and downward force would be equal. Okay.
Yes, sir.
And let's say that if we had something like this, so something is pulling in this direction F1 and something is pulling in this direction F2. And this is at equilibrium. So what would be F1 and F2? F1 would be what?
So both of them will be equal, right?
Yes. So that is,
Fi cap.
yeah. Yeah. So this is F minus, this is Fi, and then this is F2 minus I. So F net is 0, so you'll get F1 equal to F. So in the right direction, the same force, left direction, the same force, right? So if somebody pulls you, right? So let's take an example of Akib. So Akib's right hand is pulled by somebody else, and the left hand pulled by somebody else, and both are both are applying the same force. So Akib will remain in the same position, right? But let's say that on the right hand side, Akib is pulled by some bodybuilder. Okay. and in the left hand side, some weak person is there. So Akib will move in which direction?
A.
In bodybuilder's direction, right? So that is how whenever the two forces are equilibrium, then that would be said at equilibrium. So then that would be at rest position. Okay, so you can think it like that. So this is the horizontal equilibrium, and this is the vertical equilibrium. Okay,
Finished,
so
sir.
finished. Uh,
Yes, sir.
Rishida, Alham, Amna, what about you guys? And if you guys have any doubts, so please ask. Okay,
Done, sir.
done. Amna and Elham, what about you guys?
Yes, sir.
Done,
Done.
sir.
So now let us do one complicated question. So we have this ceiling, right? And some mass is hanging. So let's say that some mass was hanging in this. Okay, and this is at equilibrium. First, let us do this problem. So we have this string, and this some mass is hanging with this string, and it is at equilibrium. So can you guys tell me how many forces are acting on this object? Yes, how many forces are acting on this object?
2.
Two. First one is what? Akif?
Gravitational force.
Gravitational force. So that is mg, weight, right? And what is the other force?
Normal reaction.
Normal applies when the surfaces are touching.
Tension.
Tension, absolutely right. So tension. Normal applies when there are some surfaces, right?
Yes, sir.
String is not so string doesn't have any surface, right? Okay, so
Yes, sir.
we have, yes, you are right about this two forces, right? So now this object is at equilibrium. First, let us draw the free body diagram of this object. So we have this object, right? This is M, and then downward we have mg, and upward we have tension. So what would be the equilibrium condition, guys? Yes, what would be the equilibrium condition?
Sir, how? Like how you're telling?
Yeah, so total upward force equal to total downward force. That is equilibrium, right?
Yes, sir.
So what would be equilibrium condition?
So T is equal to mg.
Equals to mg. So this is what Akib is saying. Rishita, Elham, and Amna. Is this correct? Is this correct? Yes. Rishita, Elham, and Amna. What about you guys? Are you guys agreeing to this answer? Yes, guys. Am I audible?
Yes, sir.
Yes, sir. Yes, sir. I agree to it.
So, yeah. So, is this correct, Rishita? Is this part?
Yes, sir.
Okay. So, Rishita is also saying that this is correct. What about
Yes,
you?
I think.
Elham. Okay. Elham answer is also same. And Amna, what about you?
Yes, sir.
Good. So, everyone is in agreement. Good. So, this would be the answer, right? At equilibrium, total upward force. So, this string is pulling it upwards, and the weight is pulling it downwards. And it is at this position, stationary position, at equilibrium. So, both the forces would be equal. Good. Total upward, total downward forces are equal. Yes, so this is the equilibrium condition. Good. Now, what happens is that you pull this string, right? So now let's say that you have pulled. So you have pulled this string. So initially it was at this position, but now you are applying some force in this direction. Some force which is 50 Newton, and this is some angle theta. And then the weight is, let's say, now weight, if we say this is 40, right? So you have 2 points. This is one point where all the forces are acting, and this is the second point. Okay, so let's say this is point O, and we have to find out this theta. So let me go back and ask you this one. So let me see that you guys remember or not. This is theta, and this is, let's say, r. So what is this component? Horizontal component would be how much with theta? What would be this?
Sir, I don't get how you're telling.
Yeah, I am saying that this part is r,
Yes, sir.
right? This is theta with which is making some angle, and this is the horizontal x, and this is y. So what would be the horizontal component? What would be this?
Cos theta,
Yeah, you are nearly correct.
A
This
cos
is
theta.
some a. So this is r. Absolutely good. So r cos theta.
Sir, it is resultant, right? R.
R is some vector, right? Some vector or anything like that. So R is some vector. Okay, this is not resultant. Uh, because we don't have any two vectors, right? Resultant comes when we have two vectors.
Yes, sir. Okay, sir.
This is some vector. Now, what would be this part?
R sin theta.
Yeah. So this. Okay. So Rishida, Ilham, and Amna, do you guys remember this part?
Yes, sir.
Good. So
Yes, sir.
now, yeah. So keeping that in mind, let us draw or let us mark all the forces at this point. Okay. So we have, right, we have this string and we have this wave. So on this object, how many forces are there? On this 4 kg mass, how many forces are there?
Sir, 2.
Two. Absolutely correct. What are the forces?
Gravitational force.
So one is 4g, right?
Yes, sir.
And the other one is what?
This tension.
Tension, right? So
7
let,
volts, right?
yeah, so in the upward direction. This is tension. Let me mark that as T. And at this point, right, at this point, how many forces are acting at this point? Yes. So this point is also experiencing some forces. What are the forces? Can you tell?
Sir, I know only one.
One. So what is that? What is
I know
that?
gravitational.
No, no. So there is no mass, right? There is no
No
mass.
mass.
Because this is some point of rope. So the rope was like this. Rope was like this, and you just stretch this or just pull this rope in this direction. So this is what to do. Let me show some example what happened. So what is happening is that okay. So this would be sufficient. So let's say this is some rope, right? Let's say
Yes, sir.
this is some rope and it is hanging like this, right? So you have this
Yes,
weight
sir.
and this rope is, now what you do is that you apply some force in this direction. Understood?
Yes, sir.
So you are applying some force in this direction and then you have these two kinds of tension. So this is the condition. Do you guys understand now the question? Yes.
Yes, sir.
Okay,
Yes.
so this was the case, right? This was the previous case. Now we have just pulled the string in the x direction. Okay, now you tell me at this O point, what are the forces? Yes, everyone, please tell at this O point, what are the forces? One is
Normal.
clearly normal. Do we have any surfaces?
Sir, down. Thus 4 kg
Down.
walk.
Yeah. So downward there is a force. What is that force? So in this rope is feeling some tension at this point as well, right?
Yes, sir.
This would be in this direction, and the amount is T2. Clear?
Yes, sir.
In the opposite direction of this point. Understood? Understood.
Yes, sir.
That is why this string is tight or this string is straight, because it is also applying or it is also experiencing the tension in the opposite direction. Tension is, or whenever we have some string, so the tension is experienced in the opposite direction, right? So this has some tension in this direction, downward. And what do we have else? What else do we have?
Sir, force is given.
Force. So in this direction we have the force. Understood? And
Yes,
do we have anything else?
sir. The mass is given.
Mass is not, there is no mass at the O point.
O point.
O point. We are calculating the all the forces at O point. So remember this is a string, right? So in the opposite direction we will again for feel, or this string will or this point will feel some tension. But this would be different because these lengths are different, right?
Yes, sir.
So is this part clear to everyone?
Yes, sir.
Yes, sir.
Okay, now you see that this tension is with some angle. And what is that angle? So can you guys tell me? Let me draw a bigger picture, right? So this is a smaller one. Let me draw the bigger picture so that it is more visible. So we have this one, and then we have this one, and then this is the force which is 50 Newton. This is 4 kg mass. So we have this 4g weight and this T2 tension. Similarly, at this O point, we have this T2 tension in the opposite direction, force in this direction, and the tension in this direction. Right. This is theta. And can you guys tell me that what is this angle?
Theta.
Why?
Corresponding angle.
Corresponding. So what are these angles?
Alternative interior angle.
So this one, corresponding or alternate interior. Yes, alternate interior, right?
Yes, sir.
So you have this kind of diagram, right? So whenever you have this Z or S, whenever you have this Z or S, so then these are the interior angles that you have. Okay. So everyone, is this clear about this angle?
Yes, sir.
Okay, so now everyone tell me that what would be this component? What would be this component?
J.
This is, yeah, that is J component. This is theta. This is T1. So what would be this? This is theta. This is T1, and this is theta. So what would be this component with the angle theta?
T cos theta.
T1 cos theta. Good. And what would be this component? This is T1 cos theta and then perpendicular path. This is T1 cos theta and then perpendicular path. What is this?
T sin theta. T2 sin
T1,
theta.
T1. This is right. So we have this theta. This is T1. So this has two components. T1 cos theta, as Akif said, and T1 sin. Clear, everyone? Is this part clear?
Yes, sir.
Okay. Rishita, Elham, and Amna, is this part clear?
Yes, sir.
So now we have to write three body diagrams, right? So how many object and points do we have where all the forces are acting? How many points are of the objects? Yes. How many?
Sir, 1 point.
1 point. Okay.
O.
Akib is saying 1 and 2. What is the? Okay, so which one is are you agreeing with? 1 and 2, or which one you are confident in? Akib, 1 or 2?
Sir, 1 point.
1 point. I'm saying that uh, totaling with the masses and points. So how many masses or points do we have in total in which all the forces are acting? So Akib said one. Rishita, Elham, and Amna. What is your answer? I'm asking that how many points or masses are there where all the forces are acting? And to remind you guys that this is at equilibrium. Okay. Yes, guys, please tell me.
Two.
Two. So Amna's answer is two. Okay. And Rishita and Elham, what about you guys?
So I think one.
Elham. Yeah, don't bother. Don't worry about what will happen if this is the wrong answer. Is somebody going to scold you or, yeah. So nobody is going to do anything to you guys, right? Nobody is gonna judge you with your answer. So feel free to answer. The important point is that we think about the question, right? So yeah, you guys think and tell. Rishita, what about you?
So even I think it's one.
One. Okay, so let us see this picture. So at this point, all the forces are acting. So this is one. But there is one more point where all the forces are acting again. So this dot, right? So at this point, we have two forces again. Is
Sir, it is object, right? How can it be a
yeah.
point?
So I said in total, how many points and object is experiencing all the forces? So did I ask this question or did I say only points?
Sir, you said total, but this is object, right? How can we take this as point?
No, no. So I said in total points and objects or masses. I said points and masses. Yeah, did I say it in this way, right, guys?
Yes, sir.
I said masses and points. or if you guys heard about, or if you guys heard only points, then I'm sorry, guys. So I was asking about in total how many points and masses which are experiencing the different kinds of force, right? So
Yes, sir.
is this clear?
Yes, sir.
Okay, so now the whole system is the equilibrium, right? So I have pulled this string, right? So this is not at this point. This point is not moved, which means that this point is equilibrium, and this thing is not moving upward or downward, which means that this point is also at equilibrium. Correct, guys?
Yes, sir.
Okay, so now let us draw the free body diagram. So let us draw the free body diagram. Good, guys. So this is what I want, right? Don't bother about the right or wrong answer. So we have these one and two things, right? So at one, okay. Let us draw this point. This is point O, and in the right hand side we have F, which is 50 Newton, and in the left hand side what do we have? What do we have, guys?
Sin theta, sir. T1 sin theta.
Given sine theta. And in the upward direction, we have what?
T1 cos theta.
T1 cos theta. And in the downward direction, what do we have?
T2.
Good. So these are the things that we have. And the second thing is that FBD at 2. So what are the forces? This is 4G, and this is what?
T2.
Good. Okay. So now seeing at the second FBD, what can you tell about the equilibrium? When will this be at equilibrium?
Sorry, sir.
When this system will be at equilibrium? This mass is
And
at,
both of them will be equal.
yeah, so T2 is equal to 4G, correct?
Yes, sir.
Or T2 is equal to 4 into G is, let's say, 10. So 40 newtons. Is this part clear, everyone?
Yes, sir.
Okay,
Yes, sir.
now let us come at this point. So now at equilibrium, the right hand side or left hand side forces are equal and the upward and downward forces are equal. So tell me about both the equilibrium conditions. First one is what?
Sorry, sir.
Tell me about all those equilibrium conditions.
Sir, opposite side should be equal.
Yeah. So what will that give?
It means T1 cos theta is equal to T2.
Absolutely right. So T2 is, or let me write it as, yes. So good. T1 cos theta is T2. Good. And then
T1 sin theta is equal to 50 Newton.
50. Good. Absolutely right. Yes, you are correct. Absolutely correct. So these are the two equilibrium conditions. Okay. Now let's say that this is 1 and let's say that this is 2. So if I divide second with 1, so T1 sine theta divided by T1 cos theta and 50 divided by T2. T2 is how much? So
T2.
then, yeah, T1 cancels and we have tan theta, which is 5 by. So theta is tan inverse 5 by. This was the question. We had to find out that at what angle this is at equilibrium. So, is this clear, guys? Is this question clear?
Yes, sir.
Yes, sir.
Rishita and Amna, what about that?
Clear, sir? Yes, sir.
Okay, so please note it down. So this part, yeah, we started with this one. Please note down that. And if you guys have any doubt, please don't hesitate. Okay, so you guys already know this part, then I will ask. Whenever you guys want me to scroll down the screen, you guys
Yes, sir. Finished, sir.
whenever you guys have completed noting it down, please.
Sir, can you scroll?
Yeah, where do you want me to scroll?
Yes, sir,
Start
down. I couldn't
down.
see.
Finish, sir.
Finished. Okay, Rishita, Ilham, and
Yes, sir, done.
done.
Yes, sir.
Okay, everyone has finished now. So I will give you guys one question, and then you guys will tell me about the answer of this question. So the question is that you have this wall and then this wall. So there is one string and then the other string, and then some mass is angle. Okay, let's say this angle is 60. Okay. So now you guys have to figure out that okay, so this has some tension, this has some tension, right? And then this will have some tension. And again, this will experience some tension. And this object has mass, let's say, 6, 6 kg or 6, yeah, 6 kg. So you guys find out what is T1 and what is T2. The system is at equilibrium. Did you guys understand this problem?
Yes, sir.
I have marked down all the forces, right? So you guys find out what is T1 and T2. Yes, are you guys solving the question?
Yes, sir.
Good. Remember how many points do we have to calculate the equilibrium condition and yeah, what are the components that we have to simplify?
Yes, sir.
Yes, Rishita, Ilham, and Amna. Yes, are you guys solving, stuck at some point, or
Solving, sir.
what? Rishita, Ilham, and Amna, what about you guys? Yes, guys.
Yes, sir. Doing it.
Okay. Yes, anyone got any answer?
No, sir.
Are you guys stuck at some point?
No, sir. Doing.
Do 1 minute more, right? And then I'll ask everyone, and then we'll do this problem together.
Sir, I'm not getting.
Okay, no worries. Yeah, so time is over.
Not getting, sir.
Okay, no worries, guys. So we have to find out T1 and T2. And we have 2 points, this one and this block, right? So let us write
Yes, sir.
it, yeah, let us write it the free body diagram of this block. So uh, let's say this is one position, then this is second position. So at one, the free body diagram is what? This is T3, this is 6G. Am I correct, guys?
Yes, sir.
Yes, sir.
So T3 equals to 6G, which is T3 equals to 60 Newton. Correct?
Yes, sir.
Now, what do we have? So now at this point, this is at some angle. So it will have two components, one in this direction and the other in this direction. What is this angle?
Sir, I cap.
Angle. What is this angle?
60.
60.
60 degree, right? This is 60. This is T2. So what is this? What is this part?
Sir, T2 cos theta.
T2 cos 60. Good. This is T2 cos 60. And what is this one?
T2 sin 60.
Sine. So now let us draw at let's say 2. So we have this point, and then this is T2 sine 60. Then this is T2 cos 60. Then this is T1. Then this is T3, which is let me write it. So at equilibrium, T3 equal to T2 sine 60. Correct?
Yes,
Yes,
sir.
And T1 equals to T2 cos 60. Clear?
yes, sir.
Yes, sir.
So we know the value of T3. So let's say that this is 1. So and then this is 2. So in equation 1. We have T3, which is T2 sine of 60 is what? Half or 3 by 2. And then this is T3 is how much? 16. So we have T2, which is equal to 2 into 60 divided by root 3. So we multiply this by root 3 to rationalize. This is 3. So this will become 20, so 40 root 3. Clear, everyone?
Yes, sir.
Yes, sir.
Now, what do we have? Now, in equation second, we have T1 equals to T2 cos 60. So T2 is 40 root 3. And how much is cos 60? Cos 60 is how much, guys?
1 by root 2.
1 by root 2. Okay. And so Akib is saying cos 60 is 1 by root 2. Everyone, do you guys agree with 1 by 2? So, yes, Rishita, Ilham, and Amna. What about you guys?
1/2.
1 by 2. Amna is saying 1 by 2.
Yes, sir. 1/2.
1 by 2. Ilham is also saying 1 by 2. Rishita, Rishita, what about you? Yeah. Rishita, is your mic working? Rishita, what about you? Yes.
Sir, I'm getting 1/√2.
1 by root 2. So we have a draw here. We have a draw. Which one? Who is correct? Akib, do you want to change your answer?
No, sir.
Okay, so what should I say?
Sir, it's 1/2.
Elham is confidently saying 1 by 2, so she is confident. Akib is also confident. So, okay, what we should do? Okay, cos 60. So, I don't want to prove this, but if you have a triangle, this is 60. So, this is 30. So, this is 30, this is 30. This is A, so this is median. This is A by 2, this is A by 2. So this would be root 3A by 2. Okay. Now if I calculate cos 60, so cos 60 is base by hypotenuse. Base is A by 2 and hypotenuse is A. So A by 2 into A. So what will I get? Yes,
Half.
half. So half is correct. But you guys should remember, right? So this is half. Okay. So, yes. So this is half, and then this is 2. So this is 20. Is this clear, everyone?
Yes, sir.
Good, good. So now you guys please note it down. Right. So where did you reach, guys? Where did you get stuck? At which point, guys? So did you guys reach these 2 points?
Sir,
Yes.
like my diagram, it went wrong. So
Oh,
answer
yes, yes.
was not right.
Diagram is very important. Yes, Saki. Diagram is very important, and this is what we have to focus on. Because
I
Yes.
wrote down the wrong values.
oh, you wrote down the wrong values, but
Yes,
you
sir. Same.
okay, okay. So oh, okay. Okay, so good, good. Yeah. Okay, so you guys please note it down, and that is what is more important. That you guys at least try, right? So yeah, attempts also get marks. So I don't know in your school whether they give you if you attempt the question whether they give you marks or but there should be marks whenever you attempt a question. Okay, whenever you guys want me to scroll down the screen, you guys,
Yes, sir. Finish.
finished. Move down.
That's
Done. So now you guys are confident that you guys can make free body diagrams, right? So if you are given three forces, tension, normal reaction, and gravity, then you guys can solve those questions. So then you guys can make those free body diagrams, right? Right, everyone.
so.
So everyone noted?
Yes, sir.
Yes, sir.
Rishita, what about you? Noted?
Yes, sir.
Okay, so the next, remembering this one, keeping this in mind, the next topic is, so we studied that our object was at equilibrium. But now what happens is that it is not at equilibrium, which means that if it is not at equilibrium, so it will have what? If the object is not at equilibrium, so it will have what?
Sorry, sir. If object,
If object doesn't have if the object is not at equilibrium, so then it will have what? Yeah, what was the crucial condition for the equilibrium?
net force should be zero.
Absolutely right. So if the object is not at equilibrium, which means that it will have what?
The net force was not zero.
Absolutely right. So that is yeah. So that is what we will do in equation of motion. In equation of motion, all the forces. So F net is remembering the second law. What is the second law of motion?
F equals to MA.
M. So F net would be equal to M. Understood, everyone?
Yes, sir.
So
Yes.
okay. So now let us solve this problem. So we have these three blocks, and some force is applying on this object, which is 10. So which is giving an acceleration to this system. Okay. So this is a 5 kg block. This is a 3 kg block, and this is a 2 kg block. So we have to write all the force, right? So we have to write all the force, okay, on each block. So these are these are connected, right? These are so their surface are connected, which means that they will have the same acceleration, right?
Yes, sir.
Whenever the surface are connected. And I forgot to tell you about this one also, that let's say if you have this object m1, and then you have this object m2. So if these are connected, and then if you are accelerating it, so it will accelerate with the same acceleration. Okay, so in here the acceleration would be same, in here the acceleration. Is this clear, everyone? If these are connected with some string, so this will have string and then this will have tension. So, but they will experience the same acceleration. Is this okay, everyone?
Yes, sir.
Yes, sir.
Okay. So now what do we have? We have a force, right? Total force is 10 Newton, right? And what is the total mass?
10
What
kg.
10 kg. Good. So mass is 10 kg. So we know that F is equal to what? MA. So F is 10 Newton. M is what? 10 kg. So A would be 10 by 10, which is 1 meter per second. Is this part clear, everyone?
Yes, sir.
Yes, sir.
So we have a net acceleration in this direction. So let us write all the things in the free body diagram. So time is over, so we will do this problem tomorrow. Okay. And you guys just think about this problem and think that how many forces would be there for this part, how many for this part, how many for this part. Okay. So how many forces for this part, and then this part, and then this part. So we have to make how many free body diagrams would be there, guys?
Sorry, sir.
How many free body diagrams would be there?
3.
Three, right? So there would be three free body diagrams. So one would be, so this is one, this is two, and then this is three. So we will make a free body diagram for 5 kg block. We will make a free body diagram for 3 kg block, and we'll make a free body diagram of 2 kg block. So we'll see that how many forces are acting on this one. Okay. So tomorrow we'll write. You guys think about it, but you can already tell, right? How many forces would be there? Which means that how many kinds of forces would be there? You guys have learned three forces. So in the three forces, how many forces would be there in this case? Yes.
So 3.
Sir,
So Alham is saying three, all the three. Okay. And Akib, yeah, you were saying something.
sir, 2.
Okay, and Rishita and Amna, what about you guys?
So 3. All
Yeah, so Amna said two, and Rishita, what did you say?
3.
Three.
All
Okay,
3 of
all three. So we have gravitational force, we have what tension, and we have normal reaction. So okay, so Akib, you tell me what are the two that